if you want to do any regression, you will start first with what? Or correlation analysis. The first point of call is what? A scatter diagram. That will give you an idea whether there's even a relationship between them and so forth. So someone said our X should be, so we go for cars 93 and X is miles per gallon. So the MPG, they are two, intercity, no, city driving and highway. Which one should we use? City, okay. And then our Y is what? Cars 93 and we are using what? Price. Like that, okay. So we do our plot and it looks like this. So first of all, we see that our labeling is not good, isn't it? So that we can do it. What I'm trying to do now is that I want to decrease the spaces around here because I don't need them. Of course, I need to write something here. So that I make it 444 and so forth. So now it's a bit better, right? So I decrease the spaces around them and so forth. What is the importance of this? When I pick this up and I paste in there, say wait, that space will not be there. So my graph will occupy the entire area rather than one where the graph sits in between and I have space around it. That is, you cannot write anything there anyway. Okay. Okay. So first, next, what do we want to do? We want to label them correctly. So S lab and Y lab, right? S lab is what? MPG for city. We can say MPG for city driving. I think that should be the main, okay. And then Y lab, we use what? Price, right? Like that. And then so now it is labeled nicely, right? Okay. Or just say MPG. So what is the relationship between MPG and price? It is what? Negative correlation. Okay. So as miles per gallon for city driving increases, the price of the car decreases. Does this make sense? Does it make sense? It means people are not interested in cars that use so much fuel for city driving. So you don't have demand, and those doing economics, if there's no demand, what happens? The price decreases. So you see the nose mask, at a point, you will get one of these for 20 Ghana cedis because there was demand. Those days when it started, a pharmacy, they said 20. So you buy like 400 or something. Now it's even 5 cedis, you get the whole pack. So that's how things are. Okay, so let's move on. Is everybody okay with this? So this one, our comment is that there exists some inverse relationship between what? The price of the car and its miles per gallon for intercity driving. Oh, in intra-city, right? Is it intra or inter? No, this is intra, within. Yeah. So for city driving. What else can we do? We can find the correlation, right? The correlation. So call, then we just copy this. Oh, I need a bracket there and there. Negative. So you were right. You were right. Okay. Now, what we want to test the hypothesis that there is what? Negative relationship. Hypothesis of negative correlation. What do we mean? If you have a hypothesis and we say we want to test whether there exists a negative correlation between price and mass per gallon. How would we do this? Is everybody okay with this? Okay. So, would this be a two-tail or a one-tail test? The question again. The question is, there is a claim, okay, that there exists a negative correlation between price of a car and the mass per gallon. I want to test this here. How are you going to think of no hypothesis? This one, I know you are done with so I want to over it. Because this one is this guy so that's why so I want to say to avoid an alternative hypothesis. So the claim is about negative correlation. So from this, I can formulate my alternative to be the claim. So my H now will be that rho is equal to 0. That is no correlation. Of course, rho is what we use to represent correlation, the population correlation. Then R will be the sample correlation. So what is my H1? It is what? Less than 0. So because of this, I could have also stated this as a rho greater than or equal to 0. That's also accepted. Because I will also reject this if it is equality or greater than. So this is a one-tail test. It means my critical reading. So critical reading will be a region of this form, right? If I have this, I will reject, no, it's the other way around. So I will reject for some small values. I reject, and this will be the non-rejection region. So let's see how we will test this. So that's now an alternative. How do we do this? Remember, call.test, right? Call.test is what we will use. Then we copy this price stuff, put it inside, and then we need alternative. So this alternative will not be the usual one, which is the two-sided. So the alternative, if I'm not saying you should have this off head. I have been doing this for years, so I can remember. If you can't, just do call.test. Okay, when you come here, they are all there, so that it is here, and then you are writing on the left. Is that okay? So the alternative, remember, I have two-sided, less and greater. In this test, what am I looking for? Less. Yeah, so my alternative is less. Then I copy this and then paste here, like that. What else do I want? The method. If I have asked you to do Kendall, then you choose Kendall. But by default, it is the Pearson's product moment correlation. So we leave it like that. What next? Confidence level is also needed. Assuming I ask you to test at 0.1%. Sorry, let's say 10%. The default is 5%. Anything apart from that, you must go in and change the confidence level. Is that okay? So please, when you are solving problems, don't be in a hurry. Even though it is examination. Pay attention to details. That's important. Okay. So if we are to test this, so let me copy it so that we test at 10%. So if our confidence level is 10%, then I'm going to change this to 0.90. Is that okay? because my alpha is 10%, so my confidence level is what, 90%. The alpha is what, the level of significance. So we are set to do this test. And there we run it and we get this. Now remember, let me do this so that we see. Remember that, oh, I want this to be right there, but it's not. It doesn't want to. Okay, good. Now we have it. So this is, let me talk about something else. We've done hypothesis testing. All of you, whether because you are all doing 2 to 3 at school, and I teach them, so you can't lie to me. Or you want to. Okay, so if I have a hypothesis test to do, what are the different ways within which I can make a conclusion? One, you can use the p-value, yes. You can use the test statistics, and what again? You can, and the confidence interval. Yeah. So here we can use T, right? And go and read the under H naught, this T will be Tn minus 2 degrees of freedom. So I can go and read, but this one, the alpha is just the alpha because it's not two-sided. Okay, so one way to do this is that here my critical region is that reject H naught if T is less than what? Tn minus 2 alpha. This is it. Because it's not two-sided. If it was two-sided, I would have divided this by what? Alpha over 2, or divided by 2. So here, do we know the number is 93? So it means that we are going to read what? T 93 0.1. So this one, if you have your table, you can read it. Because you have R will not give you any table. So if you want to read it, you do QT, quantiles of the T distribution. Your P is 0.90. For this one, you even want to read the lower limit. So you can use 0.1. 0.1, and then GF is equal to 91. Is it? No, it's 93, so this should be 91. So you can read it enough. And then you compare your T, which is negative 7 point something, over there. So, in other words, we will reject for, I don't know the value, has somebody done it? But all of them will lead you to the same conclusion. Let me see. So this is QT. So let me say critical value. So this is what we call the critical value. And what does that mean? It is the value that separates your what? Your rejection and then what? The non-rejection region. 0.1. DF is equal to 91. So of course this will be negative. So you see this is negative 1.29. Negative 1.29. So what is my T? The T is negative what? 7 point something. So I come here. Where is negative 7 point something? It will be somewhere here. So what does that mean? We do what? Reject H naught. And what is our conclusion? There is a significant negative correlation between what? Price of car and the mass per car. Is that okay? Is it okay with everyone? Okay, so that is one way. One way was to use the t value or our test statistics, and then we read the critical value from table, and then it tells us to decide. Another way round is to use the confidence interval. Remember here, we are interested in 0, right? Okay, so, but because this is a one-sided interval, we are going to get an interval from negative infinity up to a point. If that point includes 0, then we cannot reject this null hypothesis. If it excludes 0, then we will say it is highly likely that there exists what? No correlation. So let's look at the confidence interval. The confidence interval is between, and remember this is correlation. Correlation ends at -1, right? So we cannot have an interval that starts from -2 because it is a value between what? -1 and 1. So you see, the confidence interval, the 90% confidence interval is between what? -1 and what? 0.5. Does it include 0? Does this interval include 0? No. So what is our decision? We reject the null hypothesis of what? No correlation. Okay? And then we have enough evidence to conclude that there exists a negative correlation, significant negative correlation between what? Price of car and miles per gallon. Is that okay? So that's another way. One more way is to use the p-value. So our alpha is what? 10%. What is our p-value? If you go up there, you see the p-value. The p-value is here. 1.65 raised to the power -10. So that is 0.0000000 and so forth. Because it is less than 0.1, what do? We reject it. So whichever way you use, you will come back to the same conclusion. Is that okay? All right, okay. Any question on this? Other than that, we move on. Can we move on? So let me go to the IA and see what else. So we've done that. Fit a regression, superimpose regression line. Okay, so we can do that as well. Okay, so now let's fit a regression line. Please, if you are not following, please, this is the last time. Don't carry your burdens. Let us help you. Like Jesus said, he said we should bring our burdens. So please don't send it away. And then Friday you go and sit there and can't write anything. I don't want to see you again in this class. So please. That's why I'm here. Other than that, I will be resting. Okay, so regression. So that you go and copy. Oh, but this one that I said 2 weeks after. So that one, when I'm marking, I'll open my eyes well. Oh, I'll open my eyes really well. Oh, so I said, you see, the BCR regression correlation, no regression. So we fit a regression line. That's what the regression line. Okay. So let's see. So fit LM. Let's see. So now we know that there exists a significant correlation between them. But in the correlation analysis, we did not have any, we had interest in all the two. Now, let's say we are interested in the price of the car. Now we know that it's influenced by what? The amount per gallon. Okay, so we said there are variations in the price of the car. You want to see what is the value? want to buy this car, this is of let's say of the CV, but one is has a customized career. So there's some variation. And in order to explain that, they say, well, it has some relationship with the human, whether with how the human consumption within the system, if you are driving within the system. So we are using that to help us explain the price in the system. Okay, so to do that, we use what we call a LM, which is linear model. And I think we've done this. And then formula. So so as I said, you don't need to memorize. If you don't, just LM. And if you you find it says fit linear model. So we want to fit a regression line, which is a linear model. So we use it. If you are using it, what does it mean? I said we just need these two. The first two is enough for us for this course. Until then, until I meet you again. If you don't want to meet me too, praise God. Okay, so now, no, I mean the following semesters. When you get to level 304, level 300, I won't meet you. I have not been teaching. Last year, I did not teach at level 300, so I hope it will continue like that. Oh, but there's some computing. If you are doing actuarial science, then it's likely I'll meet you. I'll meet you again on this same thing. Well, now our focus will be on actuarial science. Yeah. Not cars and so forth. So the formula is this. That now we want price. So I always want to get my data first. My data is what? Cars 93, right? Okay, so my formula will just be price. And in order not to make a mistake, I'll do this so that we know that you can make a mistake. Remember there was price, right? So price per order is the formula, which means price on what? Mass per. Okay, so that one was mpg dot city. Okay, so I'm going to do this. I know I'll make a mistake. I made a mistake, so I will not get what I want. And so I'm making that mistake so that we correct it. Okay. So what does it say? Price offer. So this gives me an indication that there's nothing in R called price with small letters. Okay. What I need to do is to go to the help files that I did on the cars. And let's look at how price is spelled. Price is with what? Capital P. So it is important that when you are doing some things like this, especially under examination condition, to cut and paste. This one is not plagiarism. Far from it. Right? This one you are avoiding trouble. So now it ran without any error. Is that okay? So don't cultivate the habit of typing on your own. If it is able, copy and paste. Copy and paste. You avoid all those trouble. That's why I'm doing that. But whenever you see not found, the first thing that will come to your mind is that you have not defined the back. So I think if it is something that you are defining, then it means you have written it as a script, and you have not run it. If it is inbuilt, and it is defined, then remember you have not. That is all right, so that you are defining your environment, but you are trying to follow it. Just example is that where is the story? Victoria is not. Okay, but I remember I used Victoria. Just to remember that. So you, for example, this data is in math. You are not doing that, you are looking for that program, not like us. You say if it is not there, you say it's there. This one. Okay. So now let's see. So we do summary. Is it time? Summary. Right. So, okay, so please do it and do summary. I'm going to run my summary again because I want it to fit on the screen and then I can explain this. Let me see if it is still, okay, so now it's okay, so now we have our audio, so we are okay. Now, remember that, please, have you been able to display your this thing so that I can collapse the top there so that can I move on? Okay, so I'm going to collapse this so that we have all the results here. Oh, no. Uh, okay, so you see, when we do this and we call summary, it first gives us the formula, right? The formula we use or the call to the function LM, price on miles per grams in the city. The data is cars 93. Now, remember, in 223, we said that what are the assumptions underlying the regression? You can't run away. Do you remember? But there was some normality. The errors are normally distributed with mean zero variance sigma squared, which means through that we'll be able to find the distribution of the y. The y's are beta naught plus beta 1x, and this variance is also sigma squared. Okay. The residuals are what you are using to estimate your like an estimate of the variance, so to speak, or the error associated with your model, because the residuals are the actual values, okay, the difference between the actual values and the predicted values on the line. Is that okay? So if all my line passes through all the points, then my residuals will be 0. Now, if you look at this, so we expect the residuals to follow, let's say, normality. Okay? So if you look at this one, would you say this is normally distributed? If it is normally distributed, we should have, remember we said 0. So the mean should be 0. The minimum should be of the opposite sign as the maximum. The first quarter and the third quarter should be the same, but in opposite signs, with opposite signs, and so forth. But that's not the case here. If you note the minimum, -10, but the maximum is what, 38, right? First quarter, -4.8. The third one is what? 1.96. So this means that it deviates from some normality, right? And so forth. But key thing are the coefficients. Now, if you look at the coefficients, the intercept is what we refer to as beta naught in our 223. So beta naught is 42.3661. And beta 1 is what? -1.0219. So from this, I can, for example, ask you to write your regression. Your estimated regression line. And if you are to do this, the estimated line is what? Y is equal to beta naught cap plus what? Beta 1 cap x. This is what we say is what? The estimated regression model. So results. We have y now is equal to 42.37 minus 1.02, right? 1.02x. Now this is what? Price. This one is the average price. And this is what? Miles per gallon. So how do you interpret this? Okay. When there is no miles per gallon, the price of the car is what? 42.27. You check the price over there. So if you are interpreting this to be in this class, and you say it's 4.237. 4.237 what? You get me? You must interpret it in relation to the problem you are solving. And if you look there on it's a price in thousands of dollars. So for a car that does not have any miles per gallon per city, what does that make sense? No. You can't run the car that car, I don't know what does it. But this is how we interpret it. If they add miles per gallon to be zero, in other words, it doesn't use any fuel, then the average price is what? 42,370. Is that okay? Now, what about this one? So for any 1 miles per gallon increase, miles per gallon is measured in what? It's the same thing. Miles per gallon. So for any 1 miles per gallon increase in the consumption of the car, the average price decreases by what? 1.02 thousand dollars. Is that okay? So this is how you interpret it in relation to the problem you are dealing with. So the beta naught, once again, is the price of the car if the car does not use any fuel. In other words, if the miles per gallon for intra-city driving is zero, then the average price should be like 42,370. However, for any, or in addition, for any 1 mile increase in the miles per gallon for intercity driving, the price of the car decreases on average by all 1.02 thousand dollars. So that's how you interpret this in relation to the problem we are dealing with. Okay. Next is the standard error. You remember the difference between standard error and standard deviation? So the standard error is always I have the standard deviation for a data. So for example, I can get your ages and then we find the standard deviation of your age, which is essentially how does it differ from what we're doing, right? We spread and we find the other. I cannot say standard error for age, because age is a variable. However, I can say the standard error of the mean, the standard error of the mean, the standard error of the mode, the standard error of the variance. So all those things are so these standard errors are for the beta naught and beta 1. Remember, I said those in my class in 223, you will do this in next semester when you come back. So you will do regression and time series and you go into this. However, here I can ask you because you don't need to compute anything. But if you look over here, this is the t value. And I expect that you should be able to use the probability, the p value, to be able to make a conclusion. What is the conclusion if you want to use p value to do hypothesis? You reject it not if the p-value is less than alpha. So if we take alpha to be 5%, you see, then we have to keep our model, the beta not in the equation. Because if p-value is very low, what am I going to say? So what this tells us is that this regression is statistically significant. Because if I'm doing this, I reject each of this. So when I do this test, I reject this one, right? I reject it. And then the second line shows that I should reject it in favor of that it is not zero. So they are significant. In other words, it must be kept in this model. If we fail to reject this one, then it means the regression may just be this, which is a regression passing through the middle, the center, or in other words, the origin. It doesn't have beta. So that's the idea. So there, I expect that you should be able to use the p-value to make a conclusion. When you come next semester and you do this, you can now go and read the t-values and so. So I'm not going to waste time there. Now, if you come down again, these are all significant codes. What it means is that it will only tell you at what level will this one will be not significant. So here, it is only when we consider zero. But that's why a proper test. If it is zero, then it means you only reject when you only don't reject when it is less than zero, then we can't have that probability to be zero. Okay. So it's really a sign. So if, for example, if we have star, so 0 is star star, 0.001 is star star, 0.01 is star, and 0.05, which is what we are using, will be dot. So in some instances, you have a dot, which means it is not significant at 0.5% level of significance. Okay. The residual, remember the residual standard error is this. The residual, those doing regression, remember our residuals is SSE, right? So the SSE, some of the residuals, and of course the original square, an estimator of the original square is SSE over N minus 2. So you get all those things over there. Another last one is this. So this one you use it for overall regression. It ties in with it. Because then I know that y is related to x. Because if this is 0, if this is not significantly different from 0, then it means I can take this one off. Which means my model itself will be some beta naught plus some random error. It's a constant model with some fluctuation or nuisance value. But if this is different from 0, it means y is related to x. Yeah. So you can also use the F statistics to conclude it. So that's about how you explain the output. Is it okay? Any question? Is any question? Other than that, then I move on. The point is this: when you fit a regression, not every regression will be significant. So, for example, this one, let's look at I even forgot this. You remember your coefficient of determination in 223. This is it. Multiple R squared. So what does this mean? Only 35% of the variation in the size of the car is explained by the regression of mass of the car. Which means the remaining 65% is not explained. Which means due to other factors. And there's adjusted on top of our legislation. from this, you should be able to also extract your coefficient of determination. In which case, R turns it as what? Multiple R squared. Because remember, your coefficient of determination is what? R squared. The correlation is what else do you want to do in the question? Let me see. Superimpose regression line. Quite easy. So we have fitted our regression line. If I want to superimpose it, I must make sure that my graph is there like this. So if I have fitted the regression model, which is fit LM. So if I say AB line is draw a line, right? So I can use this. Just pass it through this one. Oh, why does this change on its own? Okay. So let me say superimpose your regression. The regression line on the graph. Oh, I must go down. The regression line on the scatter plot. On the scatter plot. Now to do that, I just do AB line. Of course, I can color this to, let's say, 2, which is red, and so forth, so that the line shows nicely. So this is our fitted regression line, okay? I can make the line big by using LWD to, let's say, 2. So it means increases. Obviously, LWD is line width. There are so many. You can even use different line type, LTY. So the color, the red line is 2, number 2. I can also do so by, if I want blue line, I can also put blue in quotation marks like this, and I'll get blue. Okay, so you can either get colors by the numerals, or you can use a color name. Is everybody okay? Is there anything we can do again? Or let's close. I think you are. So the coefficient of determination, you know it. How to interpret it, you should know. We know how to predict sales. So the prediction, you use predict. So predict, if you go to predict, okay, object. I think you should use predict LM. This one, predict LM, which is linear models. That will show you more. So the new data. If you come here, it says new data is what? An optional data frame in which to look for variables with which to predict. If omitted, the fitted values are used, and so forth. So what are the fitted values? They are just the values of y for the corresponding x values you use in plotting the x. Now, if I want new values, then if you come here, you must have new data. And if you scroll down, you will see how the new data is, where is new? New is a data frame, see. So if I want to do this, let me go to my plot. So I have, let me say I want to predict let's say 32. If you remember this, F is 32. Sorry, S is 32. What is the value for the miles? Sorry, the price. Of course, if you were to do this on a graph, you trace 32 over here, and then you trace it horizontal, then you say maybe 12,000. I can also do it for you. Okay. But before you do it, you must provide the data frame of X. So I'm going to do two things. I'm going to do C32, and also I want to predict outside the range of this line, right? 50. So my new is this. So if I want to predict, I'll say predict LM. So this one is prediction, right? Prediction. So I want to predict. I'll call my object. The object is equal to my fit LM, which is the model you have fitted, and the new data. Please, as I said, you can go to the help and copy and then you do it. I know. That's why I'm not going there to copy and paste, but I rather write and then I choose. You may not be able to do so as of now. So this one is new. So let's see our predictions. It says was error in predict new environment object MPG city not found. Is it new data? Object new data. Okay, let me see. Or data. Do I need data here? Let me see. MPG city. This new. Okay. So if I So if I predict, I get my fitted values. And if I want new data, so these are the first one is 16.89 and so forth. Now, if I want, okay, so new data, not X, but mpg.city. There. And then now I say new data is equal to new. There. Okay. So, okay. So if I want to predict, you see there, let me do it on the board. There's, if I fit my regression, like what we did is like this. So I fit my regression like this. This is less than 30 to 35. Please, can you listen to this? I fit my regression line like this, and I want what is the value for miles per gallon 32. I will trace this over here, and I will trace it down up to here, and then I will use the line down. Now, if you want to do that, I will be able to provide it for you. What you need is that you use the function predict. Okay. Of course, we can add ln, but predict will also do it for you. Then, what is your model? The model we use, the name was fit ln. But we must provide it with new data. If we don't provide it with new data, it will just list all the points. Remember, this one, its fitted value is here. Right? If I take this value, its fitted value is somewhere here. If I take this, it is somewhere here. So some of the values, the line over predicted, others the line under predicted. So the differences over here is what you call your residual. Is that okay? So the actual value is this, but the line tells me this is a predicted value. So we call this one the predicted values on the line or and so forth. So if I do only predict without anything, it will give me all the values on the line. However, because 32 is not in what I did, if I want to predict it, then I must provide that with new data. Okay? So I wanted to see those in my class. I said, we don't extrapolate for regression. You can, but you have to be careful because if you don't have data there, maybe the line does not exist over there. You will see that it doesn't make sense. What I did was 50. So if a car runs on 50 mpg.city, its price is actually negative. What does that mean? It means it's like you are even paying to dispose of the vehicle. Do you get it? It doesn't make sense. You know, in some countries, sometimes even interest rate is negative. So they are paying you like Japan to even come to take the money. Do you get it? So it doesn't make sense that I have a car, but because its engine capacity is so big, I have to pay somebody to even take it. That's how it is, because you are actually, running a loss. If it's price and it is negative, that is a loss. Yeah. So, but it may not necessarily be the case that if your engine size is so big, you have to pay for somebody to take it. So that's what extrapolation and regression may be wrong. And so forth. So I use this example as well. So what I wanted to do, what I did was that I provided the new data, and the new data should be a data frame. So you must, and this is why we started with what? Data type. So you create a data frame, give it some new miles per mpg.city values, and then I will now predict its value over here. So that's what we have done over there. And in this case, we predicted for 50 and 32. So when the miles per gallon per city is 32, the price is around 9,663. And if the miles per gallon is 50, it is actually negative. It's negative data. So I think that should be enough for the night. And I wish you well. Okay, so now we have predict holiday sales for customers. Yeah, this you should be able to do it. Draw vertical and horizontal lines. It's easy. If you go to AB line, the same. AB line, that's one way of doing it. A is no, B is no. If you A and B, the intercept and slope. And it can be single values as well. If I want to write a line, I want to draw a line, and I'm using A, B line. I give it the slope and the intercept. One other way, remember there's H and B. H and B are horizontal and vertical. If I want to draw a vertical line, I can give the vertical line. If value of one will be the same two at the other. If I want the horizontal line, if value of y will be the same for each value of x and then the vertical one. So for example, here, if I want to If I want to see the value for, let's say, 20, I can say AB line with H is equal to 20. So horizontal line 20. I can maybe color it, let's say 8. So the color, I don't know the 8 color, but you see there, it's like gray. Um, let me give a line that will be 2. You can do something. If I want a vertical line, I can also do so. I can also provide them at a goal. So I can do, let's say, 25, and also a vertical line at, let's say, 35 or 30, something like that. And color, maybe they are all should be red. So I can do them at a goal. But you can also let them end at point. So that at where they intersect, they don't go wrong. So you can end it. So, yeah, there's so much you can do in that. I think I have introduced you enough to most of the things, and you should be in a position to okay. So here I didn't talk about it, but the fourth one, can you conclude that every sales of women are greater than that of men? This is a hypothesis testing question. So you must get the average sales for women